Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we have discussed about the Friedel-Crafts oscillation reaction. In that what we had seen, we had looked at oscillation of naphthalene by succinic anhydride yields a mixture of alpha and beta isomer or the products. And look at the still I have represented there the reaction. The starting material is a naphthalene, where the reagent which we have added is a succinic anhydride in presence of the AlCl3 Lewis acid, and the solvent is employed there is a nitrobenzene, and therefore we got or the yield of the product yields are two isomers. We are getting a mixture of the product or the isomer. One is a group which is introduced at alpha position, that is alpha naphthyl propanic acid, and the another one is a beta naphthyl propanic acid. These are the two mixtures we are getting, and as I told you, there is a problem for separation of the mixtures if more than two products are obtained, and there is a different technique is used to separate that two mixture from each other. So up till now we have discussed. So now today what we are going to discuss, so let us see. Next point which we are going to discuss is oxidation. Oxidation in terms of the organic chemistry. How do we define the oxidation? Very simple. If there is a removal of hydrogen atom from the substrate or the reactant is known as oxidation reaction, and the reduction reaction means it is exactly opposite. Removal of hydrogen atom is known as a reduction reaction. These are the simple definition for oxidation and the reduction in terms of the organic chemistry. In terms of the inorganic chemistry, oxidation means loss of electron is known as oxidation, and reduction means gain of electron is known as a reduction. So these are the different terms defined in a different way in a different chemistry, means in organic chemistry and in terms of the organic chemistry. Organic chemistry means the study of compound that contain carbon, and the rest of the study of the element or compounds are known as the inorganic chemistry. That, and in terms of the melting points are there. As far as organic chemistry is concerned, the melting point of that organic compound is always less than 350 degrees centigrade, while the inorganic mixtures are what we can call it as the element, they are very high melting point, near about as a 4000 degrees centigrade, like as a tungsten which we are using in the bulb or in a so you can see the lights over here. So that's the major differences between as organic and organic and the inorganic. Now today the oxidation, seventh reaction, because we are discussing about the reaction of the naphthalene, that is the seventh one is the oxidation. Oxidation reaction, where the oxidation will takes place or carry out in case of the naphthalene. So here a part, oxidation of naphthalene by atmospheric oxygen in presence of V2O5 vanadium pentoxide destroys one ring and yield phthalic anhydride. Oxidation of naphthalene containing side chains lead to the formation of quinones with chromium trioxide in presence of acetic acid at room temperature that gives that product. So that, as I told you, oxidation means removal of hydrogen atom is known as oxidation. Here we are talking about the reactions of naphthalene. As we know that this is a structure of naphthalene. This is a structure of naphthalene, and we want to carry out the reaction of oxidation here with atmospheric oxygen heated in presence of He2O5 vanadium pentoxide, where one of the ring get oxidized. The naphthalene is smoothly converted into phthalic anhydride. See how the reaction takes place, and it gives very good compound with high yield, that is nothing but as a phthalic anhydride. This is known as a phthalic anhydride, and which is one of the reagent used for the synthesis of many organic compound. This phthalic anhydride can be obtained by using the naphthalene with atmospheric oxygen heated, and the catalyst is used here vanadium pentoxide. Now what is the use of catalyst using in this reaction? It will speed up the reaction, oxidation takes place smoothly, and we will get very high yield of that product. So this is one of the example of oxidation of naphthalene here we have seen. Now second one, when that substituted naphthalene, let us see methyl group. Let us see another example over here how the oxidation can be done. Here let us take the substituted naphthalene in this case. So here I am showing the example of methyl naphthalene, or this is a substituted naphthalene we can call it, or we can give number 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is a numbering system always followed in naphthalene. So the methyl group which is present at 2 positions, so we can call it as a 2-methyl naphthalene. 2-methyl naphthalene. This is a compound. When these 2-methyl naphthalene oxidation reaction takes place in presence of strong oxidizing reagent like CrO3, chromium trioxide, in presence of ACOH. ACOH is nothing but as a solvent acetic acid. The reaction carried out in acidic medium at 25 degrees centigrade is nothing but as a room temperature, sometime it is called, and the resulting compound obtained will be the 2-methyl 1,4-naphthaquinone. Means, as most of you might be knowing the structure of quinone, and here the compound which we are going to get over here, C double bond O, and this methyl group is there. So this moiety is known as a quinone. The 2-methyl, the name of this compound starting from 1, 2. So 2-methyl, the quinone system, quinone group or carbonyl group, they are present at 1, 2 position. So we can mention here 1, 4, because 1, 2, 3, 4. Another means second carbonyl group which is present at 4 position, and therefore it is written like this: 2-methyl 1,4-naphthaquinone. This is known as a 1,4-naphthaquinone. We can call it as 2-methyl 1,4-naphthaquinone. So that is a IUPAC name of this compound which is written over here. So This is the example of oxidation reaction, how naphthalene can be oxidized by using different oxidizing reagent, such as in a previous example we have seen simple naphthalene which would be carried out in presence of atmospheric oxygen and vanadium pentoxide used as an catalyst, and the reaction takes place, or the formation of the product which is oxidized product, that is nothing but as a phthalic anhydride. So that is one of the example we have seen, and this is the second example where the substituted naphthalene is taken here and the strong oxidizing agent used like CrO3 chromium trioxide in presence of acetic anhydride stirred at room temperature 25 degrees centigrade, and the resulting product obtained. The name of the resulting product or the product is a 2-methyl-1,4 naphthaquinone. This is the quinone moiety present, and therefore it is known as a quinone. Now let us move on to the next and the last reaction of naphthalene, that is a reduction of naphthalene. Let us see, that is a reaction number 8, that is a reduction. Reduction, as I already told you at the beginning of this lecture, in terms of the organic chemistry, how do we define the reduction? Reduction means removal of reduction means addition of hydrogen atom in the substrate, or you can call it as a reactant, and the resulting compound or the leading compound is called as that reaction is known as a reduction reaction, because naphthalene itself is an unsaturated compound. When the hydrogen is added, that unsaturation, a higher degree of unsaturation is converted into as a saturated or less unsaturated one. So that type of the reaction are known as a reduction. Let me recall once again the definition of the reduction in terms of the organic chemistry. The addition of hydrogen atom is called as a reduction reaction. Vice versa, oxidation reaction means what? Removal of hydrogen atom is called as an oxidation reaction. So these are the simplest definition which are present in the organic chemistry and which I have just. Now is the reduction. And reduction, naphthalene can be selectively reduced by choosing proper reagent and maintaining proper condition, giving different reduced products. Look at very important sentence they made over here. Reduction, about the reduction, naphthalene can be selectively reduced by choosing proper reagent and maintaining proper condition, giving different reduced product. See here, the starting material which I am taking is nothing but, see here, this is the starting compound which I have taken. Here is a naphthalene, right? This is the structure of naphthalene, and we are learning the reduction of the naphthalene By using the proper reagent and maintaining proper condition, we would get different reduced product. So let us see here the three ways which can produce the product. Number one, when it is treated with, here I am writing 2 in bracket, square bracket, hydrogen atom, when I use C2H5OH in presence of sodium, that is a sodium in presence of ethanol, when I am using and keeping the temperature at near about 78 degrees centigrade, what I am going to get, there is a partial reduction occur, and the compound which we are going to get like this is the product which I am going to get partial reduction, where I am going to get over here one of the bond, total number of double bond present in naphthalene are 5. Out of that 5, if you count the number of hydrogen atom present in this resulting compound will be 4, means one of the double bond is reduced, means there is a partial reduction occur when we use proper reagent and maintaining the proper reaction condition. We will get this compound, the name of this compound would be 1,4-dihydronaphthalene. At 1, 2, 3 and 4, at 1 and 4 position there is a CH2 groups are there, and therefore these kind of the compound are generally referred as 1,4-dihydronaphthalene. 1,4-dihydronaphthalene, which is a compound we will get by using the compound when we use the reagent like this. Now, in the second case, when I am using sodium metal in presence of isopropyl alcohol, and temperature is raised about 132 degrees centigrade, what I would get there is a reduction. The reduction will be this one. Let us see here. Only one ring which is aromatic and one is a saturated ring is obtained. And if you see over here 1, 2, 3, 4. Here in first example, if you observe the structure carefully, what would you find? You will find 1,4-dihydronaphthalene, means at 1 and 4 position there is a 2 hydrogen atoms are there. But in case of second, there will be one ring is completely saturated, and the CH2 at 4 position 1, 2, 3 and 4, there are CH2, 4 CH2s are there, means one ring is completely saturated. The position where the hydrogen atom is added at one position, so 1, 2, 3, and 4, there are 4, so you should say 1, 3, 4 tetrahydronaphthalene. This will be the name of this compound, which we got over here. And when if you use the reducing reagent here, the common reducing reagent H2 in presence of nickel, that is a Rane nickel, or you can use either you can use platinum. What would be the product when you use H2 in presence of nickel or platinum or palladium? The resulting compound, that naphthalene is completely reduced over here, and that compound becomes as a saturated, and that the name of this compound, which is the compound known by its common name, that is a decalene. Decalene. So that is a common name of this compound, is a decalene, which we can obtain very easily by using these different proper reagent and maintaining as a proper reaction condition. We would get partially reduced or different reduced product. You can observe here there are different product which I have shown on that here on the blackboard. You can see clearly. So in this way we have seen some of the example of naphthalene which gives the electrophilic substitution reaction. But in forceful condition or in a special condition, naphthalene can show nucleophilic substitution reaction in special conditions. Now, how they will show, at what position nucleophilic substitution reaction can occur, what would be the proper reagent, and what would be the proper maintaining proper reaction condition, that I think we will discuss in our next lectures. So today just we have seen the reaction of naphthalene, whatever reaction we have seen up till now from 1 to 8 different reaction, all are the example of electrophilic substitution reaction. That are the important characteristic feature of aromatic compound that I have explained up till now. In forceful condition, in a special condition, at what position, whether at one position or whether at two position, is the naphthalene alone or substituted naphthalene undergoes nucleophilic substitution reaction, at what position, is there any known or the named reaction is there or not. That kind of questions answer we will try to get in my next lecture, means tomorrow's lecture. So with this, let us wrap up the today's lecture. Thank you. Have a nice day.